Hey everybody, this is an answer key for the Unit 7 study guide for trigonometry. Um, we've gotten to the end of our trigonometry unit, which means I'm going to send you a unit test for this unit. Okay, but it'll be just like this study guide, so I thought I would give you this study guide and also a video showing you how to do this so you can practice, and then you can do the test and take pictures of it and send it back to me, and you can do the test open book as well. So let's go over the study guide here first. I will call mine answer key, and the test will look very much like this. You'll get these formulas here. A squared plus b squared equals c squared. That's the Pythagorean theorem. SOHCAHTOA for primary trig ratios in a 90-degree triangle. Angles in a triangle add to 180 degrees. And of course, you can do this test using your notes and things like that to help you if need be. Okay, so number one, find the missing side using the Pythagorean theorem. Okay, so remember you have to identify the hypotenuse because that is C in the formula. The hypotenuse is always across from the 90, so that is C. And once you have C, it doesn't matter how you label A and B. So since we're trying to find this side X, we've called it A. We'll go a squared plus b squared equals c squared. A is the x that we want to find, so x squared plus b is 35. 35 squared equals 40 squared. Okay, so now we have to solve for x. It's being squared, and then we're adding 35 squared, so I'm going to subtract 35 squared from both sides. And we will get x squared equals, and I'm going to go 40 squared, take away 35 squared, and get 375. Square root both sides with a plus or minus in front. And we will go x equals plus or minus. We need the square root of 375, which is 19.4. And since we're finding the length of a side of a triangle, we reject the negative answer. Okay, so x is equal to 19.4 millimeters. All right, let's do part B. We're solving for a side. We have two of the other sides. Across from the 90 is C in the formula. We can use the Pythagorean theorem in a 90-degree triangle. And so it doesn't matter how you label A and B. So C squared is equal to A squared plus B squared. C has been replaced by Y, so Y squared is equal to 13 squared plus 8 squared. 13 squared plus 8 squared. 233. So y is equal to plus or minus, and let's do the square root of that 233, and we get 15.3. And it's the length of a side, so y is equal to 15.3 millimeters. Again, okay, and again we'll say reject negative answer. Okay, number two. Boat B is 12 kilometers west of boat A. Boat A travels directly north to get to shore. Boat B travels 30 kilometers directly to the same point, so boat B would be along here, 30 kilometers to the same point. How much shorter is boat A's trip? So you have to figure out x here, first of all, that length, but then you have to figure out how much shorter that is than boat B's trip. So how much shorter this x is than the 30 kilometers. Okay, so there's an extra little step. Okay, so they're showing that it's a 90-degree triangle, which means Pythagoras and SOHCAHTOA applies. When you have two of the three sides and you want to get the third side, we can use Pythagoras. Across from the 90 is C, so we could call this one A and this B. And go A squared plus B squared equals C squared. A is X, so X squared plus 12 squared equals 30 squared. And now let's get x by itself. So subtract 12 squared, subtract 12 squared. X squared is equal to 30 squared. Take away 12 squared, which is 756. Go square root, square root. So x is equal to the square root of 756, which is 27.5 roughly. So technically, mathematically, we would have plus or minus 27.5. We are going to reject the negative answer. Okay, so x is equal to 27.5 kilometers. And then we can say, therefore, boat A's trip is 30 kilometers minus 27.5 kilometers, which is equal to 2.5 kilometers shorter. Okay, so there's that extra little step. How much shorter is boat A's trip? Okay, 2.5 kilometers shorter. All right, number 3, write the required ratio in fraction form for the following triangles. Excuse me. I don't have corona, my children, just sort of an allergy cough. Okay, sine alpha. So there's alpha. Across is opposite. Across from the 90 is the hypotenuse. So that's the adjacent. Hey, remember, opposite and adjacent end up switching if we talk about angle beta. So we'll get to that in the next set. But sine alpha, remember, to do this, we've got a 90-degree triangle, so SOHCAHTOA applies. Sine is opposite over hypotenuse. The opposite is 7, the hypotenuse is 25. Okay, so 7 over 25. Cos is adjacent over hypotenuse, so cos of alpha, the adjacent is 24, the hypotenuse is 25. And tan is opposite over adjacent, so tan of alpha would be opposite 7 over adjacent 24. Okay, and now when we start talking about angle beta, things switch here a little bit. There's angle beta, which means the 24 now is the opposite. That's still the hypotenuse. The 25 is still the hypotenuse because it's across from the 90, and so the 7 is going to be adjacent. So sine of beta, sine is opposite over hypotenuse, so we would do 24 over 25. Cos beta, cos is adjacent over hypotenuse, so cos beta, the adjacent is 7, the hypotenuse is 25. And tan beta, tan is opposite over adjacent, the opposite is 24, the adjacent is 7. Okay, everything looks good with this. Excellent. Okay, number 4. For each of the following triangles, find the indicated side or angle. For each question, 1, label the triangle sides, OAH, opposite adjacent hypotenuse. 2, write the trig ratio you'll use to solve. And 3, solve the angle or side to 1 decimal place. Okay, so in A, they want us to figure out that side x. There's the angle you have. Across from the angle is the opposite. Across from the 90 is the hypotenuse. So we are looking for the opposite, and we have the hypotenuse. Opposite and hypotenuse. And so if we think SOHCAHTOA, which trig ratio deals with opposite and hypotenuse? That's sine. So I would simply go sine of 34 degrees is equal to x is the opposite over hypotenuse is 15. Okay, and so to get x by itself, it's being divided by 15 right now. So we multiply both sides by 15. And we will end up getting x is equal to 15 times sine 34 equals, and we get 8.4. All right, let's get on to letter B. We're trying to find y there. There's the 23-degree angle. This is the opposite side. Across from the 90 is the hypotenuse, which is what we're trying to find, leaving this side to be adjacent. Okay, so we're going to be working with adjacent and hypotenuse, and if I look at my acronym over here, adjacent and hypotenuse comes from cos. So cos of 23 degrees is equal to 13 over y. Okay, and remember when we have this kind of equation, what ends up happening is the y and the cos 23 switch spots, and the reason for that is because you start by multiplying both sides by y to get rid of the divided by y. And then see how we will have y cos 23 degrees equals 13. And then we would have to divide both sides by cos 23 degrees. And you see how the cos 23 ends up underneath the 13. Okay, so yeah, you can see how like the y and the cos 23 just end up switching spots in that case. 13 divided by cos 23, and we get 14.1. And they don't have any units like millimeters or centimeters or anything, so we'll just leave it like that. Okay, and finally in part C, they're wanting us to find an angle. They've indicated this angle here, alpha. So they want us to find an angle. Across from the angle is the opposite. We have that side, so we're going to use that. Across from the 90 is the hypotenuse, which we don't know. And so this must be the adjacent. So we're going to be working with opposite and adjacent, which is tan. So you would simply go tan alpha equals opposite 12 over adjacent 9. And remember, when you have the ratio and you're looking for the angle, you have to go tan inverse. Okay, so you go shift tan, 12 divided by 9, and we get 53.1 degrees for that angle. All right, number 5. For each of the following word problems, sketch a good diagram which has all information labeled on it, including missing side. Write the trig ratio you will use, solve and write a sentence which tells what you solved for. So A, an observer standing 9.8 meters away from a flagpole measures an angle of elevation of 57 degrees to the top of the pole. Okay, so here's what we have. We've got flagpole, the observer is 9.8 meters. Who's knocking? I'm doing a video. No, I can't right now, buddy. I'm doing a video for my classes. Sorry about that, everyone. An observer standing 9.8 meters away from a flagpole measures an angle of elevation. Okay, so the angle of elevation is the angle moving up from the horizontal here. So the angle of elevation up to the top of the flagpole would be this one here. And they're saying that that is 57 degrees. And we assume that this is 90 here. Okay, and what it wants us to find is the height of the flagpole. So why don't we call it H right there. Okay, then label the sides of your triangle. Across from the angle is the opposite. Across from the 90 is the hypotenuse, meaning this must be the adjacent. So we're working with opposite and adjacent, which is tan. So tan of 57 degrees is equal to H over 9.8. Okay, and to get H by itself, multiply both sides by 9.8. (9.8) divided by 9.8 is 1, so we end up with H equaling 9.8 times tan 57. Okay, 15.1 meters, so that's the height of the flagpole. Okay, letter B, an observation tower is 88 meters tall. The angle of depression from the top of the tower to a historical marker is 25 degrees. So here's our historical marker. And the angle of depression from the top of the tower is 25 degrees. The angle of depression is the angle that you go down from this dotted horizontal line. So the angle of depression down like this to the historical marker, that is 25 degrees. And hopefully you'll notice that that's actually not inside the triangle. So we have to use the angle of depression to get an angle inside the triangle. Okay. And the question says, how far from the base of the tower is the marker? The base of the tower is right here. So how far is this historical marker away? We're looking for that X length. Okay. The other piece of the puzzle is from the dotted line to the tower like that is 90 degrees. And so if the angle of depression is 25, you go 90 minus 25, which is 65, to get the angle inside the triangle. So now there's the angle that we have. Across from it is the opposite side. Across from the 90 is the hypotenuse. So this 88 is the adjacent. Okay, so we're looking for the opposite, and we have the adjacent. So I think that's going to be tan again. We would do tan of 65 degrees equals opposite is X over adjacent is 88. And And since x is being divided by 88, I would multiply both sides by 88 to get x by itself. And so x is equal to 88 tan 65, which is 188.7. And that is going to be meters. Okay, so the marker is 188.7 meters away from the base of the tower. All right, number 6, for each of the following, solve for the indicated side. So in this case, they want us to find from x all the way to y, and that's made up of this small line segment plus the next one. So basically what we have to do, guys, is we have to find this distance, let's call it little x, and this distance, call it little y, and add those together. Okay, so in the top triangle, here's the angle that we have. So across from it is the opposite. That's what we want to find. Across from the 90 is the hypotenuse, which means this 20 must be the adjacent side. So I'm actually going to write this down below. Let's go adjacent. Okay, so we're working with opposite and adjacent, which is tan. So tan of 40 degrees equals opposite divided by adjacent, y over 20. Okay, and to get y by itself, multiply both sides by 20. Y is equal to 20, tan, 40, bang. 16.8. That's going to be meters, okay, because the adjacent is in meters. Okay, now we'll go down to the bottom triangle. See that 23 degrees? Across from it is the opposite, so we want to find the opposite side. Across from the 90 is the hypotenuse, so the 20 is adjacent again, so that's convenient. So we are working with adjacent and opposite. So that's going to be tan again. We would go tan of 23 degrees is equal to x divided by opposite divided by adjacent. And then multiply both sides by 20. That cancels to 1. And so x is equal to 20 tan 23, and we get 8.5 meters. So we can say, therefore, the length capital X to capital Y is made up of that little x length plus little y. .5 meters plus 16.8 meters. So we end up getting xy equals 25.3 meters. 8.5 plus 16.8. Bang, 25.3 meters. Okay, so there's 6A. That's what we would call an addition question, right? Two triangle problems. In letter B, they want us to find MN. This one is going to be a subtraction question. Okay, because what you do is you use the whole big 90-degree triangle to get the distance from O to N. And then you use this smaller 90-degree triangle here to get that distance from O to M. And then we subtract those two lines, right? We subtract these to leave this little piece right here. Okay, so first things first, let's get the larger side, call this y, we'll call this one x. To get the length y, we're going to have to use this whole big triangle right here, right? Because we want to find this whole distance from O to N. So there's the angle, 24 plus 14, which is 38. Across from the angle, this will be the opposite side. Across from the 90 is the hypotenuse, so this must be adjacent. Okay, so we're going to be working with opposite and adjacent. That's tan. So it's tan of 38 degrees. So you have to add those two little angles together. That equals y divided by 14. Multiply both sides by 14, and we are going to get y equals 14, 10, 38, bang, 10.9. It's going to be millimeters. Okay, and now let's figure out x. For x, we're just using the 24-degree angle, and the x is going to be the opposite side. Across from the 90 is the hypotenuse, which means this 14 will be adjacent again. So again, opposite and adjacent. So it would be tan of 24 degrees equals the opposite is x divided by the adjacent is 14. Awesome. And then go times 14 times 14. X is equal to 14, 10, 24. .2 millimeters. And then we can say, therefore, the length mn is going to equal the whole y length, take away the x length, and it will leave us that mn piece. So 10.9 millimeters minus 6.2 millimeters. Mn is 4.7 millimeters. Alright, in letter C, we're supposed to find DE, which is this guy here. And this is a stepping stone question because we have a side and an angle in this top triangle. So we could use that to get this side, which gets us into the next triangle, and then from the y we can get the x. That's why it's a stepping stone. Okay, so here's the angle in the first triangle. Across from it would be the opposite. Across from the 90. Sorry, I put adjacent. Across from the 90 is the hypotenuse. Okay, which means this side is adjacent. That's not going to come into play. Okay, so we are looking for the opposite, and we have the hypotenuse. That comes from sine. So sine of 68 degrees is equal to opposite over hypotenuse. Times 15.4 times 15.4. That dot is another symbol for times. So we will end up getting y equals 15.4 sine 68. And we get 14.3. That is going to be millimeters. And so now what I can do is I will put that this side is 14.3 millimeters. And now we can work in this triangle and use this angle. Say this is the opposite side. Across from the 90 is the hypotenuse. So it's the hypotenuse in this triangle. And this side will be adjacent. So I'm looking for adjacent, and I have hypotenuse. That comes from cos. So cos of 31 degrees is equal to 14.3 divided by the adjacent x that we're looking for. And remember, when we have an equation of this type, the x and the cos 31 will switch spots. And so you simply go 14.3 divided by cos 31, which is 16.7. So dE, which we've labeled x, is equal to 16.7 millimeters. Okay, which I have done incorrectly, unfortunately. Shoot. Sorry about that, guys. We are working with adjacent and hypotenuse, so it is going to be cos 31, but remember, cos is adjacent over hypotenuse. The adjacent is x, and the hypotenuse is 14.3. Sorry, so rather than having a division here, we are going to have this multiplied by 14.3 on both sides. So x is equal to 14.3 times cos 31, which is 12.3. And that's going to be in millimeters. Okay, so dE is equal to 12.3 millimeters. Okay, number 7. Two cabins, A and C, are located a distance apart on the bank of a river. On the other side of the river from the two cabins is a boathouse, B. Okay, so this is the boathouse over here. It is 420 meters from cabin C to the boathouse, and the angle at cabin C between the boathouse and cabin A is 15 degrees, just shown in the diagram here. From cabin A, the angle between cabin C and the boathouse is 70 degrees. Okay, so just like the diagram. A, find the length of x. Okay, so in this triangle we have an angle and a side, so we can use it to get x. Across from the 15 degrees is the opposite side. Across from the 90 is the hypotenuse. So we're going to work with opposite and hypotenuse, which is the sine ratio. So you go sine of 15 degrees is equal to x divided by 420. And then multiply both sides by 420 to get x by itself. So x is going to equal 420 sine 15 degrees. And we end up getting 108.7. And that's going to be meters. So I'll put 108.7 meters right there. Okay, and then part B wants to know how far is cabin A from the boathouse. So they want us to figure out this length here, y. How far is cabin A from the boathouse? Okay, we now know that this side is 108.7. We've got that 70-degree angle. So again, this is the opposite side. And across from the 90 is the hypotenuse. Okay, so we're going to use opposite and a hypotenuse again. So it will be sine of 70 degrees is equal to ultimately that x that we found, 108.7, divided by y, the hypotenuse. Okay, so this is one of those cases where those switch and you will get y is equal to 108.7 divided by sine 70 degrees. 108.7 divided by sine 70, and we get 115.7. Okay, so how far is cabin A from the boathouse? 115.7 meters. And that is number 7. Alright, we are finally on to number 8. Two office towers are 50 meters apart. From the top of the shorter tower, the angle of elevation to the top of the other tower, which is 200 meters high, is 65 degrees. So that's what they're saying right there, angle of elevation. How much taller is the taller tower? Okay. So, how much taller is the taller tower? We need to figure out this distance right here. Boom. And since the buildings are 50 meters apart, that little dotted line across will be 50. And so to figure out this y length here, the y is the opposite side. Across from the 90 is the hypotenuse. Okay, so this 50 must be the adjacent side. So we're working with opposite and adjacent, so that's going to be tan. Tan of 65 degrees equals opposite y divided by adjacent 50. And we are going to multiply both sides by 50 to get y by itself. Y is equal to 50 tan 65. And we end up getting 107.2 meters. Okay, so that's how much taller the taller tower is than the shorter tower. Okay, so then in part B, determine the height of the shorter tower. That's going to be x right here, which would match up with this distance right here. Okay, so if the y is 107.2 and the whole height of the taller tower is 200, we would just subtract those. Okay. X is equal to height of shorter tower, which is equal to 200 meters minus 107.2 meters, which is equal to 92.8 meters. And finally, part C, determine the angle of depression to the base of the taller tower. Let's say from the top of the shorter tower, so the angle of depression. So the angle of depression from the top of the shorter tower to the base of the taller tower is this angle of depression right here. Okay, and what we're going to have to do is, remember we just found this x length to be, that 92.8. And we know that this guy is 50, because that's the distance between the two towers. So to get this angle of depression, let's call it alpha. Across from alpha, this is the opposite side. The 50 is the adjacent. So we're going to use opposite over adjacent. So that will be tan. And you simply go tan of alpha equals 92.8 divided by 50. And to get the angle, you do tan inverse of 92.8 over 50. So shift tan 92.8 divided by 50, and we get 61.68 degrees. A bunch of decimal places, so you could, if you wanted to, go to one decimal place, or you could even say 62 degrees. Okay. Alright, so there you go, everybody. Those are the solutions to the Unit 7 Trig Review. Okay, and I will send you the trig test along with this, and you can do the test and then send it back to me, and the test can be done open book. Alright, so this is your learning task for this week, everyone, and I will talk to you again next week. Alright, thanks everyone. Keep being safe, and I will talk to you soon.